In this section of programming the MR1, we're going to look at the idea of conditional statements. And a conditional statement, otherwise known as a binary selection, or an if then else statement, or more commonly these days as an if this then that statement, basically works on the premise that you start with a decision. The decision is a binary decision or a true-false question that must be answered, and you do something depending on the outcome, and it's represented in flowchart like this. You've got the flow coming in at the top, you've got a condition that happens, and if it's true, the condition is true, then you do what is on the left hand side in this diagram, and otherwise you do what is false on the other side of the flowchart. Before we can actually do this with our MR1, we need to understand what our MR1 can do, and what it can do is basically the functions that we have defined in the last video. So if you haven't already watched that, you might want to watch part 5 now. But basically we can get distance, so we can get the distance that the ultrasonic sensor senses from an object. We can move forward, we can move backwards, we can stop all motors, we can turn left, and we can turn right. So that's the things that we've programmed it to do so far. We could program it to do more. We could program it to do a wiggle or something like that, but we haven't done that so far. So we're going to concern ourselves with what we've programmed it to do so far, and we're going to limit this down to a few decisions. What we can do is we can get the distance, and that can be a condition because the distance can change. So let's just say in this case, if the distance is less than 20 centimeters, we're going to do something. We're basically not going to worry about moving backwards, turning left, or turning right at this moment. You could actually put this in the situation, but we're not going to. So basically we've got the situation here where if it's false, we're going to move forward. So if the distance is greater than 20 centimeters, we're going to move forward. If it is less than 20 centimeters, which this will be true, we're going to stop the motors. So the robot's basically going to drive up to an obstacle and stop around about 20 centimeters away from it. So that's what we're aiming to do. And if we actually look at our code, if we convert this into code, we've got the ability to use the code following. We'll get the distance, open and close brackets, and always end off our line with the semicolon. Then we're going to put the if distance is less than 20 centimeters, and that's basically going to be what's in the diamond there. What happens if it is true is what we do first. So if it's true, we're going to stop all the motors. Then we're going to put in our ability to deal with a false situation, which is otherwise known as the else. And we're going to move forward if it's not less than 20 centimeters. So if it's further than 20 centimeters away, we're going to move forward, and then we're going to close that off. Let's look at what that looks like if we copy and paste that into our code. So all we need to do is put this code in here. So get distance, if distance is less than 20, stop motors, otherwise move forward, into our main loop. And then you'll see, as I'm trying to demonstrate on the screen, or actually with the robot here, is that you'll pull the box out of the way, it will move forward. If you put the box even further away, it will continue to move forward until the box is approximately 20 centimeters away. You'll notice that the robot's not tracking straight, even on this surface, which is a little bit more grippy than the slippery surface I was using before, and that's primarily because the motors are slightly different, and we're going to hope to fix that up with the gyro in future tutorials.